This conference will now be recorded.
Awesome. Thanks, Elena. Can you hear me okay? Am I good?
Yes, sound great.
Okay, great. So hi, everyone. Today, as Elena mentioned, I will be talking about a couple tools that the USGS and the Federal Highway Administration have developed to facilitate the assessment of the potential effects of stormwater runoff. And I will be focusing on updates made this past year to the Highway Runoff Database to support highway stormwater practitioners with access to monitoring data and statistics. Okay. So today's presentation will include an overview of both the Highway Runoff Database, abbreviated HRDB, and the Stochastic Empirical Loading and Dilution Model, which we refer to as SELDM. I will also go over the latest features of the Highway Runoff Database and demonstrate some of its uses, including how it can be used with SELDM for highway runoff analysis. All right. So USGS and Federal Highway commonly work together to provide research, methods, and tools to assess the potential effects of highway runoff on receiving waters. The Stochastic Empirical Loading and Dilution Model, SELDM, and the Highway Runoff Database are two among a suite of tools and publications that have been developed to help state DOTs and other agencies make science-backed decisions about resource management. And these two snapshots show the opening screens of both SELDM on the left and the Highway Runoff Database on the right. Both tools are in Access databases using the Forms function, which makes them very easy for anyone to use. You don't need to have any programming, language skills, or anything like that in order to use these tools. So now we'll talk a little bit about SELDM. So this graphic is a very simple representation of a stream that receives stormwater runoff from a highway crossing over it. It shows the upstream load, the highway runoff load, and the downstream load. In addition to these, SELDM also includes the ability to simulate the effect of stormwater control measures or best management practices, or BMPs. So where you see something referring to a highway runoff load, that could also be a BMP discharge. So the upstream and highway concentrations are stochastically simulated in SELDM, and that upstream and highway concentration are based on statistics from published data sets, and they are then summed to determine the downstream load. The highway runoff concentrations in particular are simulated as random variables using the frequency factor method, with the average, standard deviation, and skew of monitored highway runoff concentrations. And that is the piece of SELDM, the simulating highway runoff concentrations, that we will be focusing on when we talk about the highway runoff database. So to kind of wrap up an introduction or overview of SELDM, the kind of information that SELDM provides is about the risk of exceedances. SELDM is simulating many storm events that represent a 30-year time period, depending on the number of storms that commonly occur in the area that's being simulated. So this example is showing the individual storm event results for highway runoff and then highway runoff after being treated by a BMP. This type of plot has probability on the x-axis and a log scale y-axis showing total phosphorus concentration. And a graph like this can allow us to ask questions like, what is the risk of exceeding a certain concentration threshold, such as 0.1 milligrams per liter, which we have here in our horizontal line. So in this case, the highway runoff discharge without a BMP is likely to exceed that concentration for about 50% of the events simulated. And then the highway discharge with a BMP will only exceed 0.1 milligrams per liter in about 35% of events. We can also sort of ask the reverse of that question. So what concentration might be exceeded in 0.5% of storms? So in this figure, for highway discharge, that concentration is about 1 milligram per liter. And then for the BMP discharge, it's 0.45 milligrams per liter. But really, what we want to talk about today is the element of SELDM that in order to simulate water quality within the model, we need to use representative input statistics, which are derived from monitoring data sets. So highway monitoring data has been collected by USGS, state DOTs, universities for a variety of purposes, and they've been published in a variety of formats and outlets. Here we have an example from a recently published USGS report out of Massachusetts. In case anyone is interested in it, we have a QR code and the report number here. But in this study, they compared monitoring data for 2 adjacent sections of pavement, one being an open grade friction coarse pavement and one being hot mix asphalt pavement. So this graphic shows kind of the design of this monitoring system, which captured all the runoff from a section of pavement and then sampled it through a weir box. And in this study, nearly every single storm event that occurred was monitored, which produced a very large data set. And monitoring data sets like this are really valuable to characterize runoff and, of course, inform our simulations. So that is where the Highway-Runoff Database comes into the picture. The database is a tool that gathers these data sets from USGS, DOTs, universities, and puts it into one database structure that can be used to generate the statistics needed for SELDM or other analyses. It was first published by USGS and Federal Highway in 2009, and it's undergone some updates to add new data sets and enhance the functionality. And the most recent update was in October 2024. The original report is shown here on the right, and a screen capture of the Highway-Runoff Database menu is shown on the left. We'll step through some of these in more detail, but overall, the Highway-Runoff Database has 5 options for retrieving data. So the first 2, you can select data for direct export. You can also select pairs of water quality measurements. You can generate statistics, which is the big one for using data subsequently in SELDM. And finally, you can get runoff coefficient information. So in this latest version of the Highway-Runoff Database published last year, we have data collected from 26 different states, which are indicated in green in the map here. And then states that had new data added in the latest version are indicated by a star. This new version includes 43 data sets, 270 sites, over 8,000 runoff generating events, over 119,000 event mean concentrations, or EMCs. The number of new entries added since the previous version are shown in the parentheses. And then there are event mean concentrations, or EMCs, for 418 water quality properties or constituents. However, the database can accommodate thousands of different types of water quality properties. And in the latest version, we added parameter information for those additional water quality constituents where data might become available in the future. So this includes PFAS, trash, microplastics, 6-PPD, quinone, On the right, we just have an image from a USGS circular zoomed in on what microplastics look like. And on the left is a snapshot of the Transportation Pooled Fund for Stormwater Management related to 6-ppd-quinone. So these constituents are receiving increasing attention in stormwater runoff management. So we've just prepared the Highway-Runoff Database to accommodate these parameters and any data related to them as that becomes available in the future. This graph shows the top 10 constituents within the most recent version of the Highway-Runoff Database. So total suspended solids, TSS, was the most common constituent. Also in the top 10, we have a couple metals like zinc, copper, lead, cadmium, chromium. We also have total phosphorus and total nitrogen. And then the last two are dissolved zinc and specific conductance. And we've also included the count of censored values within this graph as well. So now we'll look at a couple examples of using the Highway-Runoff Database. One of the primary uses is to generate the statistics that you need for SELDM. So SELDM needs the average, standard deviation, and skew of those event mean concentrations, EMCs, in order to simulate highway runoff concentrations. So when we select the Generate Statistics for water quality data in the database, there are some pretty simple menus that you need to interact with. So retrieving data is as easy as a few clicks. You can first, or in that first menu on the left, you'll select the constituent that you are interested in. And then, so here, phosphorus was selected as an example. And then next, you'll select a data set. The way that these data sets are named allows you to see the state that the data was collected in, as well as the approximate year for that data collection effort. And then you can also select sites from within that data set. So again, these screenshots or examples were kind of interested in looking at phosphorus data for a Massachusetts study and all of its sites. The final screen that you'll interact with provides some statistical output options, including the option to calculate statistics for a grouped set of EMCs, or we can treat each site individually. The option to show the alternative methods for censored data is also available, which can help some users save some time, or processing time to explore those methods. But yeah, there are several options here, and there are question marks to the right of everything that you can always click on if you don't know what something means. So once we pick the options that we want, we can click that Proceed Calculate Statistics button. And from there, an output is generated. And this output is in a tabular format, so you can save it as a text file, or you can easily copy and paste it right into Excel. At the top, there is a summary table in the data output file, and that'll give you all of the sites that you selected and some of the pertinent site characteristics. So this format helps easily compare characteristics among selected stations. You can also easily export it into another program that you might want to use as well. This image shows a fraction of what's provided in the output because we wanted to highlight that a new site characteristic in this version of the Highway-Runoff Database is the inclusion of the impervious fraction of the 1 mile radius of the highway site, which is a useful feature to identify relationships between concentrations and site characteristics. So for example, in this Massachusetts study, the amount of suspended sediment in highway runoff samples was shown to increase with the amount of impervious surface, but this wouldn't necessarily be observed by looking at the impervious fraction. So further down in the output, we can take a look at the actual statistics that were generated. So again, this is in a tabular format. It's also formatted site by site, where each row is a different site, and then to the right we have the statistical data or information. So in terms of simulating a SELDM, we could select the median statistics among all of these sites, or you could select the data for just the site that best represents what you're trying to simulate. So to kind of bring this home, we're looking at a screenshot of a menu in SELDM where we can add those water quality statistics for highway runoff that we generated in the Highway-Runoff Database, as we showed in the last screenshot. So we can use those as inputs to SELDM, and from there we can do a simulation. So we'll kind of continue with this example and evaluate the efficacy of stormwater treatment for total phosphorus from a highway runoff site. So if we run those numbers in our simulation in SELDM, we can get results like this. So we can interpret these results from our simulation for total phosphorus. This is similar to the graph shown earlier in the presentation. We have the highway runoff and the BMP discharge, as well as the upstream storm flow quality, as well as the downstream receiving water concentrations with and without a BMP. So this figure is just meant to be an example to demonstrate, the workflow of how you use the highway runoff database to get those statistics, and then run SELDM and end up with information and graphics about the risk of exceedances for a constituent of interest and the efficacy of stormwater treatment. All right, so we'll hit on one other example of using the highway runoff database. So for this, we'll look at the paired water quality option. The highway runoff database provides output of paired water quality data for regression analysis. And this could be helpful to leverage large data sets of common constituents in order to get estimated values for a constituent that we might have much fewer data points for. So one example of this, this graph shows the relationship between total suspended solids and suspended sediment concentration. As you might recall, total suspended solids was the most common constituent in the highway runoff database. However, total suspended solid method can be biased, and suspended sediment concentration could be a better method for evaluating water quality. So we can use the highway runoff database to develop a regression between these two constituents, which we can then use to estimate suspended sediment concentration using our regression line, plus or minus random scatter, which is shown here by the gray points. So those are stochastically simulated suspended sediment concentrations. Another example of using this feature in the future might be to estimate 6 ppd quinone from perhaps zinc concentrations, or maybe estimating PAH from total suspended solids or suspended sediment concentration. So what this does is it just makes it easy for you to get the pair of highway runoff concentrations and develop a regression like this for subsequent analysis. So finally, I just want to point everyone to our SELDM webpage. It has a lot of the USGS and federal highway work there. It also has links to SELDM and the highway runoff database software, data and reports. The QR code on the right will take you there, but it's also a pretty easy link to type out. It's just usgs.gov/SELDM. So I've been talking about version 1.2 of the Highway Runoff Database, which was published as a science-based data release in October 2024. And this is just a snapshot of its science-based data release landing page. And the QR code on the left can take you to that landing page. So just to summarize, today we gave a quick overview of the Highway Runoff Database and SELDM, which are easy, accessible tools that facilitate the analysis of potential effects of highway runoff. The Highway Runoff Database was recently updated with more data and constituents and improved statistical outputs in October. And the Highway Runoff Database input statistics, the Highway Runoff Database can provide input statistics and data for SELDM or other stormwater analysis. Finally, if you have any highway runoff data that you would like to add to the database, you can contact me or Elena, or our general SELDM email is at the bottom right-hand corner. It's just seldom@usgs.gov. But if you reach out to us, we can help you get that going and add your data. So that's all I have. Thank you, guys.